Welcome to solving rational equations and inequalities. We're going to start off by factoring the denominator. We've got to be able to factor the denominator so that we can find the least common denominator. So in this first problem here we have x squared minus 2x, so we want to factor that, which is x times x minus 2. Once we factor the denominator, what we want to do with rational equations is we want to get rid of the denominator. So once we factor the denominator, then we can multiply by the common denominator. Now step 2 can actually happen at any point after step 1, which is determine what those excluded values are. So the excluded values are your restrictions to your domain. So x cannot equal 0 and x cannot equal 2. So we'll get back to that. That once again just goes back to our rational functions that we had talked about in our restrictions. We're going to be looking at that for a little different reason, but at some point after you factor your denominator, you need to determine your excluded values. Now we want to multiply by the common denominator. So everything gets multiplied by that common denominator. Well, what's the common denominator? In this case, the common denominator is x times x minus 2. You want to include every factor that is being used. So what I'm going to do is I'm going to kind of show you, and this can be a little bit lengthy in terms of me showing you this, but I do think it's important for some of you guys to see this. So as I multiply, everything gets multiplied by my common denominator. So what I'm going to do is I'm going to say, okay, first term 1 over x. Alright, that's being multiplied by x times x minus 2. That's your first term. Plus your second term, 3 over x minus 2 times x minus 2, once again your common denominator, is equal to 4 over the factored form x times x minus 2 times that common denominator of x times x minus 2. And if we multiply by the common denominator, every term gets multiplied by that, then things should start canceling, and that's what we're looking for here. So I'm going to go through and cancel any common factor. So on the first term, we have x times x, not x times x, we have this x divided by this one, so that would cancel. Alright, on the second one, we have x minus 2. This is a factor, so that x minus 2 cancels with that one. So once again, you're left with a 1 in the denominator. And then on the last one, this x cancels with this one, and then the x minus 2 cancels as well. So once again, you're left with 1 across the denominators. And now you can just multiply with what you have left. So we have 1 times x minus 2, so this one. And I'm going to leave it in brackets just so you can see each part as I go along here. Plus, now we have 3 times x is equal to, everything canceled there, so we are just left with the number 4. So I'm going to get rid of the brackets now that you can see the 3 parts. X minus 2 plus 3x equals 4. Now you're just left with the linear equation, and you solve. So you combine your like terms, add 2 to the other side, divide by 4, and you get 6/4, which reduces to 3/2. So I'll bring back over kind of the steps here. We see if I can make it a little bit smaller, maybe. There we go. We multiplied by the common denominator, we solved for x, and now we want to check with our extraneous solutions. The nice thing about this is we actually don't have to plug it back in to find our extraneous solutions. We just have to check with the restrictions that we created before. Or that we had before. So this and this go together. So my restrictions were x could not equal 0 and x could not equal 2. Well, neither one of those values are my solution, so x equals 3/2 will work. You don't have to plug it back into the original problem. If you did, it would get a little crazy. So that's the nice thing, is you don't have to plug it back in, you just have to check against your restrictions. So that's how you solve rational equations. Let's take a look at another one. Alright, so on this one, first step is to factor the denominator. So kind of the same thing on the first one. You factored the t squared to t minus 4 times t. And now everything in terms of your common denominator, you have t times t minus 4. So everything gets multiplied by that common denominator. T plus 4 over t times t minus 4 over 1 plus 3 over t minus 4 times t minus 4 over 1 is equal to negative 16 over t times t minus 4 times your common denominator. And so I showed kind of that long step there, but for a lot of you this will be important because you can see things canceling. This t cancels with this one, so you're left with the 1 in the denominator. This factor of t minus 4 cancels with this one. Once again, you're left with the 1. This t and this t cancel, and this factor of t minus 4 cancel. And so once again, your entire denominators are 1, and now you can just multiply what you have left. So on the first one, you got t plus 4 times t minus 4. So I'll write it out so you can see each of these. So once again, this is what's in the first term being multiplied, plus 3 times t is equal to, and everything canceled there, negative 16. So you want to start simplifying this. You can multiply the two binomials. That leaves you with t squared minus 16 plus 3t is equal to negative 16. It's a quadratic. Last one was linear. This one's a quadratic, so we set it equal to 0. Add 16 to negative 16 and you get 0 there. So that makes this a little bit easier because now we can factor out a GCF. And we get 2 possible solutions. We need to check it against our restriction. So kind of that step 2, but I'm doing it later on, which is fine. You just need to know what t cannot equal. So t cannot equal 0 and t cannot equal 4. Where am I getting these things from? That comes back from the factors of the denominator. So these are the values that t cannot equal, 0 and 4. Does that affect anything in terms of my solutions? Well, yeah, t can't equal 0, and one of my solutions was 0. So that is not a solution. So that one's out. T can equal negative 3 though, so there's your one solution for this problem. Once again, you do not have to plug them back in, you just have to check against the restrictions. Alright, let's go ahead and do one more of these that's a little bit different here, just to kind of give you a different idea, because there's a lot of different things that you could see here. The first two factors are already done, so on this one you could factor out a negative 1 so that you're left with an x squared minus 9x plus 14. So the signs are going to change because you're factoring out a negative 1, and then that will allow you to factor factors of 14 that add to give you 9 is x minus 7 and x minus 2. And so your common denominator is x minus 2 and x minus 7. The negative 1 you don't need to necessarily worry about because it's not anything that you're canceling. You can use it if you want, but our focus is really on the factors with the variable, which is the x minus 7 and x minus 2. So everything is going to get multiplied by those two factors. So 1 over x minus 2 times x minus 7 times x minus 2 over 1, so you can see how that's going to cancel that one, minus x minus 3 over x minus 7 times your common denominator of x minus 7 and x minus 2 is equal to x plus 1 over negative 1 times x minus 7 and x minus 2 times x minus 7 and x minus 2. And now go through, cancel. Everything in the denominator should cancel. X minus 2, x minus 2. And this one's supposed to be a 7. x minus 7, x minus 7, and then on this one, x minus 7, x minus 7, x minus 2, and x minus 2. Now you still have that negative 1 on bottom, so just make sure you include that in the numerator. So all the rest of these are 1. So multiply straight across. We got 1 times x minus 7, so that's just x minus 7. Once again, just put them in brackets so you can see them. On this one, we have x minus 3 times x minus 2. I'm going to go ahead and save myself a step. I'm going to go ahead and multiply those two together. So that's x squared minus 5x plus 6. So that's just multiplying these two things together to get this. Is equal to, everything canceled besides the x plus 1. And don't forget that negative 1. So what do I do with that? Well, if this is being divided by negative 1, everything inside there gets divided by negative 1. So we actually want to write negative x minus 1. Okay, and that has to do, as I said, with that negative 1 being divided by there. So you can see that that's why the signs change. And so let's simplify again. We have x minus 7 minus x squared plus 5x minus 6. We're distributing the negative sign. And then we're left with the quadratic, so we need to solve the quadratic. I'm actually going to, let's see, try to show my work here. Negative x squared, combine my like terms, so that'll be plus 6x, and then minus 13. And then so I get a positive x squared, I'm going to add everything to the right side of the problem. So I'm going to add x squared to this side, I'm going to add x squared to this side. And I'm going to do that with all the terms. So that would leave me with a positive x squared. If I subtract 6x, that'll be minus 7x. And then if I add 13, that'll be plus 12. And there's my quadratic. And then you can solve it. So that'd be x minus 3, x minus 4. And then you can set those factors equal. So x would be equal to 3, and x is equal to 4. And once again, that's potentially what they are. So we've got to check against our excluded values. So x cannot equal, from the restrictions above, 2, and x cannot equal 7. And so neither one of those are a problem. So we want to write our final answer since it's a set. We want to say x is equal to the values of 3 and 4. And there you go. So solving rational equations, you guys need practice on this. You need to work on these. There's different variations of these types of rational equations, so make sure you're aware of all the different possibilities that you can have. Alright, last problem here is on solving rational inequalities. Now the first step you can see is you want to solve like a rational equation. So let's go ahead and do that before we ever get to the second step. Now this one's a little bit easier. You don't have as much stuff going on. Your common denominator is just x minus 5. So everything gets multiplied by x minus 5, which means this is going to cancel and just leave you with 2x minus 7. And then on the left hand side, nothing cancels, so you're left with 3 times x minus 5. Alright, so all I did was take this times this quantity and this times this. So now we need to distribute, I don't know what that was. 2x minus 7 is less than or equal to 3x minus 15. Subtract the 2x, so that's x minus 15, and then add the 15, so you will get 8. And so x is greater than or equal to 8. Now that would be nice if that's all we had to do. That seems pretty easy, but not quite that easy. We need to divide the graph by the solutions and the excluded values. So we got a couple of things here. We got x is greater than or equal to 8, but we also have the excluded value as x cannot equal 5. So there's two things here that we have that we need to include on our graph. So what we're going to do is we're going to graph the x-axis. We have a value of 5 and we have a value of 8. And so we break our graph into 5 and 8. Now we know 8 is included, so we know it's equal to 8. And it does say it's greater than or equal to 8, but we have to be careful with that. And we know that 5 is not included. That's actually a vertical asymptote that's happening right there. And so what we're going to do is we're now going to test each section of the graph to determine the solution. So we're going to pick a value from this section. It can be any value you want that's less than 5. Typically I try to pick something close, so I'll pick 4. Anything in between 5 and 8, I'll pick 6. And then anything greater than 8, and I'll pick 9. And what you're going to do is plug these numbers back into the inequality and see whether it's a true or false statement. So, for example, I'm going to test x equals 4. So I'll plug 4 back in. 2 times 4 minus 7 over 4 minus 5. And we want to see if it is less than or equal to 3. And so that'll be 1 over negative 1. So that's, when you simplify that, that's negative 1 is less than or equal to 3. Well, that is a true statement. So that means this part of the graph is part of your solution. And then we'll do the next section. We'll test x equals 6. So we'll plug values in. For 6, we'll plug in 2 times 6 minus 7 over 6 minus 5, and that needs to be less than or equal to 3. So that's 12 minus 7, which is 5. 5 over 1 is 5, so 5 is less than or equal to 3. Well, that is false. 5 is not less than or equal to 3, so this part of the graph you won't do anything with because it's not a true statement. And then we'll do one more section. We have at anything greater than 8. So at 9, what happens? Well, this is 2 times 9 minus 7, and 9 minus 5. And is that less than or equal to 3? So that's 18 minus 7. So 18 minus 7 is 11. 9 minus 5 is 4. Is 11 fourths less than or equal to 3? Well, 11 fourths is 2 3/4. So 2 3/4 is less than or equal to 3, so that's a true statement. So that means everything to the right is also true. So we have true, false, true. And so there's our solutions to the rational inequality, but we still need to write them and not just graph them. So we want to say all values that are less than or equal to 5, or values that are greater than or equal to 8. And so there's your final answer. So with rational, you have to be very careful. You're not just doing the part where you're solving. That's part of it, but the majority of the part is actually dividing your graph up by not only the solutions, and be careful here, because it's not just the solutions. It's the solutions and the excluded values. That's what breaks the graph up on the x-axis. And then you're going to do your points, and you're going to test them. Now, a lot of times you will see true, false, and they'll rotate, but not every single time. So you do need to test those points and make sure that you have them in the right location. All right, that is it for rational equations and inequalities.